Circumference of head, this should be 0.1 centimeters because it's at the first decimal, right? And therefore this will be 0.05 of a centimeter. If uncertainty is stated on its own, you don't need the plus or minus, but it's actually a good habit to include that. In this case, we have 0.01 of a centimeter because it's on the second decimal place. This would be 0.05 of a centimeter. So again, we'll change a little bit the way I mark this. The way I would mark it, right? This would normally be 1. This is half. Today you can just go check mark X, whatever. I don't really need you to add up the marks. 3 decimal places. So you just got to make sure there's a 1 on the third decimal place. You divide that. You get 3 zeros and a 5. And there we have it. So these are like the basic. Here's the number. Just figure out the answer. Then we've got diagrams. When you have a diagram, you either guess or kind of estimate, or you use this formula, right? High minus low divided by gaps. That's the one I would use for a diagram if you're not sure. So this is my high, let's say. This is my low. And I count 1, 2, 3, 4, 5 gaps, right? 5 gaps in between. So we're going to go 90 minus 80. That's 10 divided by 5. That's 2 psi. Pounds per square inch. That's how you measure pressure, right? Tire pressure in particular, psi. So 2 psi. So whatever unit you get thrown, right, just use it. 2 psi. So it's 1 psi is the uncertainty. Over here, remember, it's from marking to marking, not number to number. So you want to kind of figure, you can go high and low again. 20 divided by 2, that's 10, right? So precision is 10 milliliters. And the uncertainty, therefore, is, 5 milliliters here, just half of that. Here, you got to kind of do a bit of extra work on the side because you want everything to look like that. So we have to figure out the precision, and therefore the uncertainty is 0.05, right? So we would write it 23.5 inches plus or minus 0.05 of an inch. That would be the correct answer. 14 1/4. Here you have a choice. I would say the precision is 1/4 of an inch, a foot, sorry, and therefore uncertainty is half of that, which is 1/8 of a foot. So that'd be 14 1/4 feet plus or minus 1/8 of a foot. And I hear the size, right? Fractions. Okay. So you can, I am quite positive that the province would allow you to write that as a decimal, and then you figure out that the precision is 0.01 of a foot. Uncertainty is half of that. That'd be 0.005. And then you would go 14.25 of a foot plus or minus 0.005 of a foot. You're going to be all right either way, okay? So whatever gets you out of that, they try not to do fractions, but if there are, yeah, yes, sure. Here again, precision is 0.001, right? It's at that 0 there. So uncertainty is 0.0005. So the measurement and its uncertainty would be as follows, right? Like this. Here, precision is 0.1 of a second. Uncertainty is 0.05 of a second. So this would be 4 minutes, 23.5 seconds, plus or minus 0.05 of a second. Okay? A 0, even if there's a 0, right, that's still the precision is 0.01 uncertainty 0.005. So you would state that measurement. Don't drop any zeros. Don't drop any zeros. Okay? That's what I want ultimately. Okay? Keep going. Any questions? Clear? This is the hint that I was giving you, which one is more precise. I would like you to at least show me this is high and low. That's 200 divided by 2, so this is 100 ml is the precision. Here, it's hard to see, sorry about that. That's 40 divided by 2, that's 20 ml. And this one is 50, right? It goes up by 50. From marking to marking, it's 50, so precision is 50 ml. So beaker B. Since, you can say this, since it has the lowest precision or lowest, smallest increment, I should say, sorry, smallest increment. What the province will not allow you to say is, oh, because the markings are closer together or further apart. That's not going to be good enough. They actually play tricks on you. If you do the math, you'll find out that one is actually smaller in precision, even though the gaps are further apart. So you have to watch out. You have to do the math and then pick the one that has the smallest. Okay? So 1 mark for doing the work, 1 mark for a correct explanation. Keep going. I'm just going to call these A, B, and C. Okay. So we've got for A, the precision is 0.1 of a foot, uncertainty is 0.05. It's very repetitive, I know. Precision is 0.01 for the second one of a foot. Don't forget your units. And for C, precision is just 1 foot, and uncertainty is 0.5 of a foot. Okay, so you just always divide your precision in half. What's the combined length of the pieces? Length, if you want to do it this way, that's fine. You've got 3.2 plus 2.75 plus 4. If you add that all up, you get, what do we get? 9.95. 9.95 feet. And the uncertainties would be 0.05 plus 0.005 plus 0.5. That would be plus or minus 0.555. It didn't mention to give it in that format, but I'm just gonna make sure it doesn't hurt. You've told us the uncertainty. You've told us what the length is. This would be the length plus or minus its uncertainty. So just if you label clearly what's what, then you still get the marks. Now, once the combine to max and the combine to min, so you've got 2 options. I think it would just be easier to add and then subtract, but you could also get the max and min of each and then add those individually, whatever works best for you. But the max is 9.95 plus this. The min is 9.95 minus. So you get 10.505 on the high end, and you get 9.395 on the low end. Again, please, if you make a mistake in B, you can still get full marks for this part, so don't leave anything blank, okay? Even if it's completely wrong in B, you still get a chance in C. All right. Carpenter is installing trim. I don't know if you know what trim is. Trim is the black little border along the perimeter of this room. It's where the floor meets the wall. It's to hide any imperfections. It's made out of wood sometimes. In this case, it's just like a plastic vinyl, I think. But anyways, that's what trim is. You need to cut off 0.5 meters to fit it. Calculate the length of the trim after being cut. So here's one way of doing this, where you figure out, no, I won't do it this way because I've been showing you a different way. Stick with the plan, Mr. Dirksen. Don't keep on mixing everything up, right? You find a precision, and then you get your uncertainty. That's 0 plus or minus 0.05, okay? That's for the piece of trim you're cutting off, 0.5. Precision is 0.1, so the uncertainty of that is 0.05 as well. Okay, that's what you're cutting off. That's what the piece you have originally. So when you do one of these, you subtract the piece that you're cutting off, but guess what? You're still going to add your uncertainties. You always add. So this would be 1.9 meters plus or minus 0.1 of a meter. Okay? So that's what you would want to do there to get the right marks. I'm telling you this most of the time, myself included, I will probably give you this already. I'll give you the measurement and the uncertainty. You just have to know, what do I do with the actual measurements? Do I add or subtract? What is the scenario calling for? And just remember that the uncertainties get added up no matter what. Okay, that's basically what we're testing you here when it comes to combined uncertainty. You're measuring 50 pieces of wood that measure this. What would be the combined uncertainty? That's all they're asking for. So you go 50 pieces times the uncertainty, 0.01. And that gives you 0.5 centimeters. Plus or minus, you don't have to have the plus or minus if it's just the uncertainty. So that's what it's asking for there. All right, so I know who was here today, so you don't need to hand this in.